Out of the blue. December 26, 2004 started as a typical sunny day in Sumatra, Indonesia, an island in Southeast Asia. Ari Afrizal, a 21-year-old carpenter, was building a house on the beach. Suddenly, the ground started to shake. Without warning, a wave crashed into him. Then came a monster wave, a wall of water 30 feet, 9 meters high. Fighting for survival. The giant wave pushed Ari inland. He was tossed around like a rag in a huge washing machine. Ari tried to cling to tree branches. However, as the water pulled back, he was dragged out to sea. Far from shore in the deep ocean, Ari first found a plank of wood to float on, then a leaky fishing boat. He survived on the milk and meat of coconuts he found floating in the storm debris. On his 7th day, Ari was lucky to find a large fishing raft with a hut on it. Finally, on the 15th day, Ari awoke to find a giant ship looming over him. Ari had just survived the most destructive tsunami in history. A tsunami is a series of huge waves triggered by a sudden movement of the ocean floor. This tsunami was caused by an earthquake beneath the Indian Ocean. In all, the tsunami claimed about 230,000 lives in 12 countries in Asia and Africa. Millions of people were left without homes, clothing, or food. Tsunamis in motion. Most tsunamis are caused by earthquakes under the ocean. Waves then speed in all directions, traveling far from the epicenter of the earthquake. A tsunami travels very fast. It can reach speeds of 600 miles, 970 kilometers per hour in the deep ocean. That's as fast as the speed of some airplanes. Shaky Earth. To understand how earthquakes cause tsunamis, think about the planet's rocky outer shell, or crust. The crust is broken up into massive slabs called tectonic plates. The plates fit together like pieces of a jigsaw puzzle. Tectonic plates are always in motion. They may slowly slide past or push into one another. Plate movement can result in a sudden release of energy. We call this an earthquake. Earthquakes give off waves of energy that move in all directions. Earthquakes under the sea send waves speeding through the water. In deep water, the waves spread out below the surface, so they are barely noticeable. However, the waves become more dangerous as they travel closer to land. Growing waves. As the sea gets shallower near the shore, tsunami waves slow down to about 25 miles, 40 kilometers an hour. Long waves begin to pile up like the folds of a rug pushed against a wall. They grow into towering tsunami waves. After a tsunami wave hits the shore, there may still be danger ahead. One tsunami is made up of a series of waves. The wavelength of tsunami waves is long. The distance between one wave and the next may be more than 60 miles, 100 kilometers. A second wave could hit minutes after the first one. However, it could also take more than 1 hour. Ring of disaster. If a tsunami is going to form, it's likely to start in the Pacific Ocean. About 85% of tsunamis strike there. Why? The Pacific is surrounded by faults, or boundaries between Earth's tectonic plates. Earthquakes, volcanoes, and landslides usually occur along faults. All these events can trigger tsunamis. The Pacific faults are so unstable that the area is called the Ring of Fire. Volcanic tsunamis. Sometimes tsunamis can be triggered by volcanoes, falling asteroids, or landslides. Krakatau. Krakatau is a volcanic island in Indonesia. Its eruption in 1883 was the most violent in recorded history. The island exploded, and 2/3 of it plunged into the sea. This triggered a tsunami. The waves were as high as 130 feet, 40 meters. Tsunami waves killed about 35,000 people. The big truth. Nature's warning. Sometimes nature tells you that something unusual is happening. If more people had been aware of warning signs on the day of the Indian Ocean tsunami, more lives could have been saved. These illustrations show tsunami warning signs. Anyone who notices these should move to higher ground as quickly as possible. Preventing future disasters. After the 2004 tsunami, people learned the importance of preparedness in reducing tsunami damage. They also learned the role the natural environment plays in tsunami protection. Many systems were put in place to protect against a repetition of the 2004 disaster. Preventing future disasters. After the 2004 tsunami, people learned the importance of preparedness in reducing tsunami damage. They also learned the role the natural environment plays in tsunami protection. Many systems were put in place to protect against a repetition of the 2004 disaster. Sensing tsunamis. The first step in keeping people safe is knowing when a tsunami forms. Scientists measure seismic activity on the ocean floor to spot tsunami triggers such as earthquakes. In addition, they use data from instruments called tsunameters. They also rely on knowledge of the shape of the ocean floor. Computers analyze this information to predict when a tsunami might strike and how big it may become. Tsunami alert. Deep in the Pacific Ocean lies modern technology that helps detect tsunamis when they first form. A tsunameter is a water pressure recorder that rests on the ocean floor. Water pressure varies according to wave height. The tsunameter sends the data it gathers to a nearby buoy. The buoy also monitors weather and water conditions on the surface. It sends all the data to a satellite. The satellite beams a radio signal to scientists at warning centers. Sending the message. Detecting a tsunami is only the first step in saving lives. Governments need to alert people of the danger in time for them to evacuate. Because tsunamis are rare in the Indian Ocean, there were few warning systems in place there before the 2004 tsunami. Today, many beaches in Thailand are equipped with siren towers. Officials decide when the sirens will be used, based on information they receive from scientists. Run for your life. Many countries now have tsunami education programs to prepare people to act quickly. School children and adults are taught to recognize the signs of a killer wave. They learn the best evacuation routes if there is enough advance warning. They also practice how to head for higher ground when waves are only minutes away. Human impact. Many scientists believe that people's changes to the environment can increase the damage caused by a tsunami. In many Asian countries, people have destroyed coral reefs to make room for shrimp farms or to make the shoreline more accessible for ships. Reefs could help shield the shore from tsunamis by slowing down the waves. Other human activities also contributed to the damage caused by the tsunami. Sand dunes on many beaches had been flattened. Many mangrove forests had been uprooted to make way for coastal resorts. Like coral reefs, sand dunes and mangrove forests help to protect the coast from tsunami waves.